For our first exercise, we're going to create a job. So I'll put the light on so you can see this. We're going to go into File, 1A, New. We're going to go down to the bottom right hand corner and click New. We're going to go ahead and name it my first name, just for, you can name it whatever you want. Hit Next. North Azimuth, if that applies. U.S. survey feet and degrees. Adjust for curvature of Earth if it matters. First point number, we're going to put point number 1 with 1,000, 1,000, and the elevation of our curb alignment that we're going to start working on. So the curb alignment is shown here on Red Rock Canyon Road as box number 3 in the curb data. And if we look up in the top left in profile view, it tells us our elevation is 555.14, so we're going to go ahead and put that in the calculator, 554.14, 555.14. And then we go ahead and hit Finish. So now we've created our job. Now we're going to go ahead and start working on the alignment. Edit Alignments for 2D. We're going to be New. POB for point of beginning. You can either have the northing and the easting and the L, or you can do it by point number. So you tab the location, and I put the point number that I just entered in the job as point number 1. And we're going to go ahead and start with a beginning station of 0. Could be whatever you want. And then we're going to go straight into horizontal alignment. Okay, looking at this plan, in the plan view, we're trying to find the tangent bearing into the PCR because we're going to calculate this knuckle. We're going to put an alignment on this. So we know that it has a northing and an easting of 1,000 and 1,000. We already know what the elevation is here. What we don't know is what the tangent bearing is into this curve. So what we do is real simple. We take the tangent bearing for number 4, which is north 1835.28 west, and we subtract the delta of number 3. So subtracting this delta from this bearing gets us a 7:00:09 northwest bearing. North 7 degrees 0 minutes 9 seconds west. So now we have our tangent bearing into the curve. We can start our alignment. Okay, starting our horizontal alignment. This particular alignment starts in a curve. So we go to Arc, and we have a radius. It tells us number 3 is a 50-foot radius. Our delta is 11.3519. We're curving to the left. You can either take azimuth or bearing. In this case, we figured the bearing. You can subtract that from 360 and get your azimuth, but we're going to go ahead and use bearing. North 7.0009 west, and hit OK. So we insert again, and we're in tangent. So we want to make this previous to the tangent before. That way we don't have to figure our azimuths, but we will check them as we go. So it tells us our next piece is 50 foot long. We hit OK. 0 plus 60.11, which is a check on the plan. Then we go into the next piece, which is number 5. Yes, number 5. So we insert again, horizontal alignment, we insert, and number 5 is 56 foot radius. Excuse me, we're an arc. 56 foot radius with a delta of 105.0321, curving to the right, and we hit OK. And if you look on your table down here, it tells you your azimuth out of the curve, 86, 27, 53. If you look at number 7 here, which is the box out, 86, 27, 53, is our azimuth out. So that's a plan check, something you always want to make sure that you're doing. 86, 27, 53 out. Like I said, we're using tangent continuing, so it's automatically figuring them. But that's a good way to check the plans to make sure there's nothing wrong. So we go back into insert in the horizontal alignment, and we are on to box number 7, which is actually a line, so we hit line, and that's 50 foot length. Hit OK. Then we insert again for the last piece, which is in curve. It's curving to the left with a radius of number 9 here. Let's move this up so we can see it. Number 9 right here. Go to box 9, and it says that box 9 is a 50 foot radius, curving to the left with a delta of 10.3109. We hit OK. And that's it for the horizontal alignment. Now we'll try the vertical. What we have here is the profile view for the curb up in the top left hand corner. What I find is easiest is to go ahead and figure all the percentages and make sure everything works with distances so you can enter it into alignment. Remember, it's important that we do our knuckles and cul-de-sacs as alignments also, because we're going to use it for most likely grading, storm drain. You know, we have a box here in the bottom right hand corner that we're going to end up calcing. Storm drain, sewer, water, gas and electric, curb. It's just one time you have to go through it, and many times that you're going to use it. So why don't we go ahead and figure those grades, and we'll come back and enter them. Okay, we're back. Took about 5 minutes, and we have all our percentages written down. So we go into insert. In the vertical alignment, VAL, our first length is 10.11 at minus 1.88, and in the bottom left hand corner gives us a check. Our station, 10.11, and our grade. So we go to the next one. 12.5 foot intervals now. 12.5 at minus 1.92. It should be a check, 5471. Insert again. Same length. Minus 1.76. Should tell us 3511 with a grade of 5449. That's a check. We continue that all the way through until we get to the end. And we'll see you at the end. Little thing to keep in mind, when you get to this distance call out, 39 feet to the low point right here, which is going to be the center of your box, you need to keep in mind that that does not equal the delta stations, so you have to subtract that out from your two delta stations, and you'll be a little bit longer to the low point here and a little bit shorter to your first delta coming out. It's very important that you get back on your stationing. I'm sure you found that wasn't too difficult. Now what I like to do is I hit OK, the green OK, and it'll ask you what you want to store it under. I stored mine under test. Then what I like to do is this arrow up here in the right hand corner, I like to export that road file that I've created to the hard drive and hit OK. That way if you ever lose anything or you power it down, you have it on the hard drive, and all you have to do is recall that alignment, start your point of beginning at point number 1 again with the beginning station, and you're ready to go. You have all your horizontal and vertical data. Also, one thing I like to do is go to point to polyline, inverse point to polyline 5C, and recall that alignment from right here. Choose alignment from list, recall that alignment, and inverse point number 2, which I have created on my horizontal alignment with these coordinates here. See if you can zoom in and see the coordinates. These are the coordinates of your ending alignment. Those are your coordinates, and if you write those down and insert them, you can inverse to your alignment, and when you inverse to your alignment, my point number 2, and hit solve, tells me it's online at station 2 plus 2197, which is a check. That's the length of all my curve data added up together. You should always check your alignments to make sure they're correct. And there's many ways to check them. We don't need to go into that, but I would always check that alignment to make sure the end is okay. And you should be ready to stake.